Okay, so the last type of chemical reaction that we have to work with in terms of predicting the products is the combustion reaction. And so we're going to use the chemical reaction template to identify the type of reaction. We're going to use the template to identify the products. If there are metals and nonmetals present, we will use the charges and crisscross them down. If it's a double replacement reaction, we use the solubility rules. Again, single replacements, activity series and solubility rules. It's a later problem. And then lastly, we'll balance the chemical equation. So here we have a known combustion reaction. And in a known combustion reaction, the reaction template is, it's CX HY, and really it's plus O2, and C makes CO2, and it makes, according to the template, H2 by itself. So here we have a hydrocarbon, which is any hydrogen and carbon stuck together in the presence of oxygen, which will make carbon dioxide and water. So in this example, my product has to be carbon dioxide. And it has to be water, which is H2 and O. And so when I look at this, the products are balanced, or the products are set up as they are because there's nothing else to change. So now all that's left to do is to simply balance this equation. So I have a C, an H, and an O. On the right side, I have one carbon, 4 hydrogens, and 2 oxygens. On the left side, I have one carbon, 2 plus 1 is 3 oxygens, and 2 hydrogens. My carbons are balanced, so I'm going to leave those alone for now. My hydrogens are not. So in order to make my hydrogens balance, I'm going to add a coefficient of 2 here, which will give me my 4 hydrogens, but it's going to give me a total of 2 oxygens over here and 2 oxygens over here, which 2 plus 2 is 4. So now I have 4 oxygens on the right side. I have 4 hydrogens on the right side, and I have 1 carbon on the right side, 1 carbon on the left, 4 hydrogens on the left, and 2 oxygens on the right. So I'm going to have to put a coefficient of 2 here, which will give me my 4 oxygens, and then everything is working out. The last one is a little bit more challenging, even though it is still a combustion reaction. So it's a CX plus an HY in the presence of oxygen. Will react to form CO2. And H2. So because this is a known double or combustion reaction, there's really nothing to change here. So my final product is going to be, it's going to be CO2. And I should probably change this. Nope. We'll just kind of clean this up for a second here. I don't like the way that it looks. So then we're going to go back to C and an O2. Jeez Louise. And then my other product has to be H2. So when I go and try to balance this one, which happens to be a little bit trickier, I'm going to have carbon, hydrogen, and oxygen on both sides. I have 8 carbons, 18 hydrogens, and 2 oxygens, and 1 carbon, and let's see, 2 plus 1 is 3 oxygens and 2 hydrogens. So again, I'm going to go ahead and balance this by going from left to right. So my carbons are not balanced. I have 8 on the left-hand side and 1 on the right-hand side. So I'm going to put a coefficient of 8 here, which will give me my 8 carbons, but 8 times 2 is 16. plus the 1 gives me 17 oxygens. I need to balance my hydrogens. And when I do that, I see that I have 18 on the left-hand side. So I'm going to put a coefficient of 9 here, which will give me 18 hydrogens, but it's also going to change the number of oxygens I have to 9. And if I have 16 plus 9, I think that adds up to 25. So now I have 25 oxygens on the left side. Sorry, not oxygens. I have 25 hydrogens on the left side. And I have 18 hydrogens. So my carbons are balanced, my hydrogens are balanced, and my oxygens are a little wonky because I have 25. Now, one of the hints that I gave you the last time we were together was to simply take the odd number of oxygens and divide it by 2, which in this case is 12.5. So if I have a 1 and a 12.5, an 8 and a 9, that balances this reaction. But because we cannot leave things like that, we're going to multiply all of the coefficients by 2, which means we're going to have a 2C8H18, 25 O2s, 16 CO2s, and 18 H2Os. And when you do that, everything balances out and it's the same. So there's nothing really to worry about there. So at this point, you're done with combustion reactions, predicting the products. And we're going to close this out by saying, if you have any questions, please, we'll talk about this the next time we meet, and there'll be plenty of opportunity to practice.